Hi, in this video, I am going through the week 3 poll for spring of 2024. In this poll, I have you do several types of extractions. I have you do classifications of the extractions, which, to be honest, are more to just make sure you're practicing the vocabulary and understanding what's happening. What I really want you to pay attention to, though, as you're going through this, is how the data changes as it goes through step by step. So for instance, in this current code, the first extraction changes iris data from a data frame to a vector. And the reason that is because it is extracting from a data frame. A data frame is a series of containers because of that list type structure where each container contains the same length of data, which means it's able to be arranged into a rectangle. However, whenever you extract from a single column, that results in you getting just the contents of one of those containers, which means that it has to be the same type of data. And by default, R then simplifies it to a vector. So whenever I extract what I've currently highlighted, that is a vector, which means that the next extraction, so everything that is inside of here, must resolve to a one-dimensional extraction method, even though this had been a two-dimensional. And for the record, even though I'm only like subsetting one of those two dimensions in this first extraction, I'm still like considering the concept of columns, which means I'm considering that the data itself that I'm extracting from is multi-dimensional, two-dimensional. The second extraction that has to occur, though, is the second one where I'm subsetting it to a single column. So again, this is going to simplify to a vector afterwards. That vector, so all the values from the third column will be compared to the number 6. That's going to generate a logical vector, which is then what is used in this final altogether extraction where we're taking this data on the left and utilizing the trues and false values from all of this on the right and obtaining just those values that we are trying to extract. And so in summary, if I was trying to describe this extraction, I would say that this is extracting the columns from the values from the second column where the third column is greater than 6. So it's a nice example of how we use these types of approaches to extract data that we actually care about and then do analyses on. If I'm trying to go through and like justify what each different category is, which isn't really a typical thing, it's more just a practice concept. We did use a one-dimensional extraction method. That's when that logical vector was used at the very end. The column dimension was subset based upon those two extractions. So this was one based on column. This was another based on column. Most of the time, a vector was used to do that. So here is your numeric vector. Here's another numeric vector. However, that last extraction was a logical vector-based extraction. And so that's why this last one is selected. Finally, the output is a vector, and that's just going to be true most of the time whenever you simplify it to the contents of a single column. And that's just because the default behavior for R, for better or for worse, is to simplify to a single vector. In this next question, we are extracting the first 2 rows of iris across all columns. So that means we are considering the concept of 2 dimensions, even if we're only currently removing values from one of those dimensions. It's still getting at the concept of 2 dimensions within iris. So this is certainly not a one-dimensional method. We are, however, only subsetting, so we're like below the original value, we are subsetting the row dimension so that it is simply shorter. We are not subsetting the column dimension. This will in fact return all the columns. And that's because this has been left blank. Anytime you have a comma inside of the square bracket, that's always going to be at least a 2-dimensional extraction, assuming that what's over here is going to correspond to an additional extraction argument. And if you leave it blank, it actually, and kind of contrary to normal R, that results in basically all of that dimension being selected. So we're subsetting on row. We're not subsetting on column. This was a numeric vector. So the values 1 through 2. Technically, it's an integer vector, but an integer is considered a type of numeric, which is more of an umbrella term for both numeric and double type data. The output of the data frame is a data frame because it is selecting multiple columns. And anytime you select multiple columns, each of those columns is actually, like in memory, stored in different locations. And so R does not, by default, simplify that to a vector. Even if it could, like even if they were all the same type of data, it does not, by default, simplify it to a vector. So anytime you have multiple columns, going to return a data frame, at least by default and without other manipulations like unlist or other functions. This next one is a very similar extraction. We are generating the first 2 rows, except here we are subsetting to a single column. So when this is run, we are subsetting the row, we are subsetting the columns to a single value. Obviously, this is not a one-dimensional method. In fact, we're like subsetting both dimensions, so most people don't miss that one. On the other hand, this is a numeric. There is no logic in this code, so there's no logical. And finally, the output is a vector. And that is one that people will miss because that last one returned a data frame. This one returns a vector because we've reduced it to the contents of a single column. And that's going to be the main thing that tells you it's going to be a vector. This next one is a little bit complicated. Strictly speaking, the use of the $sign, much like the use of the double square bracket, is actually utilizing the list type structure that underlies how data frames are stored in memory. And so I actually kind of removed certain questions about what type of extraction it is. However, I have clarified in the text that it's a one-dimensional like extraction. At least here, we know it's a one-dimensional extraction method. Had I just left it like this, I could see going back and forth. So don't worry about that so much. Like I said, the classification isn't so important. The paying attention to how you need to modify code in order to accommodate the changes in the data structure, that's what's key here. So in this case, we are using a numeric vector, this right here, and not a logical vector. The output is not a data frame. In fact, as soon as this runs by itself, it's now a vector. This is further subsetting that vector down to the first 2 values in that vector. It is equivalent to saying iris 1 through 2 sepal length. As long as you get those quotation marks. However, the difference here is that this is using a 2-dimensional extraction method, whereas this one used a 1-dimensional extraction method. But they would result in the same data. And yeah, so it returns a vector. This next one, I just went through that next one. It's basically the same thing, except for this time we are utilizing a 2-dimensional extraction method. And so there is a subsetting of the row dimension. There is a subsetting of the column dimension. So both of those are checked. There's a numeric, and in this case, I definitely used a character vector. The output is still a vector. There was no logic. It was only one column. That's why I'm not going to select data frame was returned. And there is no one-dimensional extraction. There's only one extraction, and that extraction has 2 arguments, which means it was accessing the 2 dimensions of the data. In this Next one, we have a numeric vector being used to subset the row dimension. We have a character vector being used to subset the column dimension. So I'm subsetting rows, I'm subsetting columns. One of those was a numeric vector. One of those was a character vector. None of those were logical vectors, so that one's not selected. Get my head out of the way. My auto framing keeps putting my head in the way. And the output will be a data frame because there are multiple columns. Okay, so now we're getting into some of the more fun ones. This one is just kind of showing some different strategies. For this example, I wouldn't normally use this to get the first two rows. What is much more typical is if I replace this 3 with something like in row minus 10 and change this symbol to a greater than. The reason I would do that is because a greater than symbol would result in all like the last 10 rows being selected, regardless of how tall it is. Very similar to like how a tail might work, a tail function. But I just was trying to keep it a little bit more simple here, but this is somewhat realistic. It's just not quite there. Regardless though, this altogether results in a logical object. So even though at this point, that value right there is a numeric object, the in row of iris is a numeric object. 1 through in row of iris is a very long numeric object, 150 values. Ultimately, the value sent to the extraction tool is a logical object. And that's because this is a comparison. So that results in logic. This is still a character vector. And so when I'm coming down here, yes, row was subset, yes, column was subset, but numeric vector was not chosen. Numeric vectors were involved, but the square bracket tool did not use it. And one thing I like to keep in y'all's mind is R doesn't know your intention. R, when it's running this in row, it doesn't know that the purpose of this in row is eventually to be used in an extraction. It's just doing what you told it to do. And because of that, all it cares about when it gets that extraction step is what all of this ended up being. Now that kind of logic usually holds true. Sometimes functions are a little bit more clever than that, and they kind of like analyze previous steps, but that's not very typical. This is a very traditional way of coding in R. So very methodical, step by step. All right. Was there anything else there? Oh, the output, still a data frame, still 2 columns. That's it. All right, so now we're moving into some more fun ones. Again, here I am demonstrating how we can create logical vectors. This time there is no numeric vectors at the extraction stage. There are no character vectors at the extraction stage. It is all logic. Otherwise, though, it's still the same. So data frame is still returned because there are still 2 columns. Yes, still 2 columns returned. I'm just going to remember how many. This next one is quite different. I would say that this is a one-dimensional extraction, but it doesn't matter because in the end, this one is definitely a one-dimensional extraction. That comma right there belongs to the C, not to the square bracket tool. And so from the square brackets perspective, it has 1 argument. That means it's going to be a one-dimensional extraction. So regardless of whether or not you classify this as a one-dimensional extraction, I probably would because it's using double square brackets, which is accessing that vector list type organization. But regardless, that first check mark becomes for sure from this extraction. I said there is a list type extraction method. So yeah, for sure, there's a list type extraction method. That's the double square brackets. That allows us to access container by container the contents of those independent containers in a list type object. This is utilizing a character vector. This is utilizing position. It's using the positions 1 and 100. A lot of students will tell me 1 through 100. That would be a colon though, not C. C is stick them together. It's a funny just quirk. And I mean, I've done it too plenty of times, but that just seems to be how our brains work. We want it to be 1 through 100. This is just 1 and 100. Output will be a vector object. As soon as this occurs, it's already a vector object because that's the contents of that container. However, this is still a one-dimensional extraction method, and indeed, it will still be a vector type of data. My puppy is upset. I've been recording for so long. The last one, I think it's the last, yes, the last one of this grouping is a complicated one that you really kind of need to break down. So I'm going to pull up R real quick just to show you what's happening. I think it's kind of a fun one. So let me get RStudio opened and probably even a little bit bigger. Oop, I lost my cursor. I don't record on the screen I'm looking at. Yeah, all right. So to make that just a tiny bit smaller. All right, so let's break this down. Well, iris is just the object. There's nothing going on outside these square brackets. So I'm going to put my cursor here. You can see how things are flashing. In order for this to complete, though, the contents has to run. So I'm going to go inside of here and try to figure out the order of operations. So I'm going to work from left to right. All of this is within a single argument, and so that's going to be independent from this over here. So let's come back to this side in a minute. That means we need to break down what's happening over here. Well, working our way inside, I can't do this comparison until these parentheses are completed. So inside of here, I can't do this, what's called a mod function, which we'll come back to, until these parentheses are completed. And I can't do these parentheses until in row is completed. So ultimately, the first thing that's going to happen in an order of operations is in row. At that point, the number of rows will be used to generate a numeric vector. Once that's done, it will be divided by 20 and the remainders will be returned. We'll come back to that. Finally, that will be compared to the number 100, and this is how the left argument will be calculated. Oh, look at me, I even spelled argument right. The right argument will be much simpler. Technically that negative, I believe, is a function, but you can just kind of treat it as a negative symbol. There is always, as with real normal kind of mathematic negatives, there's always a bit of confusion when it comes down to like, where is that negative? Is it a negative or is it a minus? So just be aware it can be confusing. You'll notice I have parentheses to make sure it's not confusing. Okay, so I'm going to break this down now. So we'll break down how this left argument is working. So the first value is the number of rows in iris. So that's going to then become 1 through 150. If I print that out, that's 1 through 150. That's just a numeric vector. I'm then going to divide those by 20 and return the remainder. And this is confusing unless you kind of jump up to the numbers that make sense. So like 21. 21 divided by 20, just think about it, should be 1 with a remainder of 1. 22 should be 1 with a remainder of 2, and so on. Well, if you go, I can't move my finger that far. If you go to the 1, well, that divided by 20 is 0 times with a remainder of 1. So when I run this, I end up getting this pattern, 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. And then it starts back over. This was 20. So 20 divided by 20 is 1 with a remainder of 0. And then it goes back to 1. And then it goes back to 1. And every time it goes back to 1, this last step becomes true. And so I can see here, it takes a little bit harder to find, position 1, position 21, position 41, 61. I'm just counting by 20s, in other words. Just a handy amount of script to allow you to detect wherever every odd number, wherever this many intervals of numbers are. I actually use this a lot to say, like, print off reports when I have something that's just kind of repeating over and over. So it's like I might repeat it. I may print off a message every 1,000 analyses just so I know how long things are taking, or even, every 100 analyses if each one takes a little bit longer. But that's what's happening here. You're generating this logical vector. So all of this results in a logical vector. I don't care about any of the intermediate steps in the sense of the square bracket tool. So that is a logical based extraction. And obviously it's extracting from the rows of iris, so that's going to be a two-dimensional style extraction. That occurs at the same time as this 1 through 3, and that one's pretty easy. It's just the values -1, -2, and -3. Now, how they get used in the analysis was kind of explained in some of these little notes, but negative values remove those positions. So we're going to remove the columns 1, 2, and 3, leaving us with 4 and 5 as a 5-column data frame. And then this is going to return each of every 20 rows. And so if I put it all together, this is what that data looks like. Row 1, 21, 41, and so forth. The 4th column and the 5th column. Kind of fun, but honestly, it doesn't take terribly long to put together once you started to learn these tools and how they can often fit together. Okay, so the next section is going through, and it is just demonstrating different styles of extractions that are very realistic. So for instance, if I told you I wanted to get the rows of iris where sepal length is less than 5 and sepal width is less than or equal to 2.5, this is a perfectly valid script because that's what's happening. This gets extracted from the column returning a vector compared to the number 5. That's a logical vector. This is a similar process that generates a logical vector, but the AND makes it where both have to be true as the final logical vector sent to the extraction function. And that's why I get a single extraction event from a logical vector that is the same length as the number of rows. Fun enough, this is the exact, let me click out of this because it messes up the formatting when I'm inside. This is the exact same process, except here I've written it with a one-dimensional extraction method. So you'll notice there's no comma inside of here that the square bracket sees, or well, otherwise. And so what's happening is the exact same process. We're extracting this vector, we're comparing it to 5, we're extracting this vector, we're saying it's less than or equal to 2.5, but finally, instead of trying to return all the columns, like I returned all the columns here we are just returning the corresponding values from petal width, where these are true. This is the same thing, but I've broken it down into multiple steps, and instead of using a two-dimensional, instead of using a $ extraction tool, I'm using our square bracket two-dimensional extraction method here to get the petal width. The same data will be returned. Same data will be returned again down here, except for this time, it's actually, I believe, the same code as this one, except I stored that logic inside of an object. This section of code is demonstrating something called which is quite useful. So here's an example of some data that might have missing values. So I'm trying to isolate values where column 2 is less than 10. So I should return this, this, and this. I generally probably don't want this in A or this in A. However, it turns out with the way normal logic works, I return 5 and 6, but then instead of returning even like this row, I actually return just a complete missing row. Note that G is not present anymore. That's a strange behavior, and it trips up a lot of analysis, especially these kind of like relational analyses where I'm really more interested in maybe, lost my cursor, in this column than in this column, but I want to kind of analyze this column based on this one. Well, here I'm expecting G, but I didn't get it. So if you want that, then you would maybe need to like detect if this is missing or is it greater than 10? And if that's the case, then you could extract that row. But most of the time, I think you're probably just wanting to omit those rows. And so which is a really good way to omit missing values. In fact, there is a function called na.omit, and I often caution, especially early learners, from using it because as you're still developing a concept of how like data should and can be manipulated, just having a function, this is what omit does, that just deletes missing positions actually tends to throw people off. What which does is it doesn't really delete anything. It simply returns the position. And so if I print off which is what I've done here, I get that from this, I get positions 1, 2, and 4. And when I use that in the extraction, it's a nice, clean extraction that's much nicer. So in summary, a which function returns the positions that are true, but this is nice because it means that I don't accidentally return missing data as part of an extraction, which can be quite confusing. In fact, a lot of the times, especially when I'm working with real data, I'm going to be putting my logic inside of which functions because that's just a very safe way to approach using logical objects. Finally, there's just some more rapid fire questions. This is going to be the values 1 through 5. So that'll be 1, that equals 2, that's false. Then it'll be 2 equals 2, that's true. 3 equals 2, that's false, false, false. This is an example of recycling. So this 2 gets repeated 5 times or recycled 5 times. They're synonymous. This next one is just going to be the opposite. It's saying it's not equal to 2. So 1 is not equal to 2, so that is true. 2 is equal to 2, so that's not true here. So that'll be false and then true, true, true. You could also just have kind of come up here and be like, all right, it's the opposite. It's the negation of that. This one is just more, are you paying attention to order of operations? So this is going to be 1 through 5 with 2 being extracted. All of that the value 2 at this point is going to be set equal to 2, or sorry, set not equal to 2, and the result of 2 is not equal to 2 is false. This one's just very similar. It's just making it a comparison. So 1 through 5, less than 3. Well, that is true, true, false, false, false. Probably the main answer I'm going to see that's wrong is this one, but that would require a less than or equal to. So there's just an equal symbol right next to that symbol right there. Just next to your less than symbol. This next one is combining an extraction with a logical vector. So this is 1 through 5, less than 3. So that's going to be true, true, false, false, false. And so 1 and 2 end up getting extracted because when I put all that together, it becomes 1 through 5 on the outside, extracted using true, true, false, false, false. I'm a jerk. So this one is just trying to make sure you're kind of isolating these steps. This is going to be 5, 4, 3, 2, 1. So, oh my gosh, I have to think through this. So this is going to be false, 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 true, true. Because 5 is not less than 3, 4 is not less than 3, 3 is not less than 3, but 2 and 1 are. Since that is then true, 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 or sorry, false, 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 true, true, this is going to return the last 2 values, 4 and 5. I know, I'm so tricky. This one's a silly example, but this is creating a logical vector using the combine function. So this is going to become false, false, true, false, true, which means we're going to end up extracting 3 and 5. This next one, just checking my answer key. This next one, this is going to be a 2-dimensional extraction. We are combining the values 3 and 5 and using that to control a column-based extraction. So what was my question? What descriptors describe the data returned by the following code? Let's go find out. All rows in row 1. No, that's not true. We're omitting all the first column, second column, and fourth column. So it can't be all rows, all values in any row. So none of those are true. The other ones are all values in like certain columns. Well, 3 and 5, since we weren't restricting any of the rows, all of 3 and 5 are in fact returned. Because that I am returning multiple columns, we know that R does not simplify multiple column extractions to a single vector, and that's why this is a data frame class afterwards. This one was, which of the following would extract rows that have numvec values between or equal to 10 through 20 as a data frame? Oh man, I'm going to mess these up as I go through. So these are always tricky because you just have to think about like, what am I trying to extract and what's going to end up being extracted. I will say that I have to do this type of analysis all the time. And you just kind of have to think about like, do I want the union? Do I want where they fail to overlap? Do I want like where they overlap or off to one side? There's lots of different combinations. And that's what I've kind of demonstrated here. So on this one, so that I don't get it wrong on this video that's been going for so long, I'm going to open up my key. For this one, I want where the rows are between or equal to 10 through 20 as a data frame. So in that situation, if the numvec is greater than 10, so like let's actually just pick out 3 values. So 5 should not be within this. So whatever is down here, 5 should fail. 15 should be between here. So 15 should succeed. 25 should fail. Okay. Well, if we run through each of those, 5 would fail because it is not greater than 10, and then this is an and. 15 is greater than 10, and it is less than 20. 25 is greater than 10, but it's not less than 20, and so it fails. And that's kind of the way you can check this. And if I go through the others, 5 is not greater than 10, but it is less than 20, so 5 would succeed. So that disqualifies this one. We could check this one. 5 is less than 10, so that is a success. Or it doesn't matter. We've already had a success for 5, so we can disqualify this one. On this one, 5 is less than 10, and it is not greater than 20. So even though this one's true because this is an and, it gets disqualified. So that's good. It should get disqualified. 15 is less than 10. 15 is not less than 10, so that's false. Okay. So that means it already fails because 15 should be included. 15 is not greater than 20, so it's also not included here. So this is actually the opposite selection. This is everything below 10 and greater than 20, which is nothing. Nothing is both simultaneously less than 10 and greater than 20. So this one returns nothing. This next one is saying numvec values between or equal to 10 and 20. Sorry, not equal or between 10 through 20. For that one, this is the right answer because it is going to be less than 10 or greater than 20. So just to go through that same example, 5 is less than 10, so it's going to get returned because this is an or. 15 is not less than 10. Also, it is not greater than 20. So 15 is not returned. So that makes sense. 25 is not less than 10, but it is greater than 20. So since that's an or, 25 does get returned, which is matching what we want. So this is the non-overlapping distribution. Finally, we have which of the following ends up selecting all rows of the data frame. So if I pick, say, any number, it is got to match these criteria. So 5 is not greater than 10, but it is less than 20. 15 is greater than 10, and it's less than 20. And then 25, even though 25 is greater than 10. So even though it's not less than 20 because of this, or it still gets returned. In other words, this selects all real numbers, whereas this one returns no real numbers. And one day I should probably not make this such a cute one because I think some of y'all pick it just because it's cute, but hopefully y'all are feeling better, especially if you've come and reviewed this video. So thank you for your time and good luck.